In the book, on page 130, we are going to talk about gas chromatography. Gas chromatography is all about the injection of a small amount of sample into the head of a column with a microsyringe. Usually, we don't know what the sample is made of. This is the microsyringe that we use to inject the sample. The sample is then vaporized. The gas sample is carried through the column by the flow of an inert gas, which means a gas that does not react with other gases. It can be nitrogen, helium, argon, or carbon dioxide, for example. So this vaporized sample will walk through the column using the flow of this inert gas and will definitely not react with it. What our now vaporized sample will react to is part of the column actually. The column contains a liquid on the surface of an inert solid that attaches it to the column. So this liquid is what will react with our vaporized sample. As the sample passes through the column, different components of the sample will separate because they will move at different rates inside the column. Now that we've separated the components of the sample, we need detectors to detect each component, and we have different types of detectors. For example, we have non-selective detectors that respond to all compounds except, of course, for the inert gas, because the inert gas will not react with it. We also have selective detectors, which respond to a specific range of compounds that have similar properties, and so they will react similarly with the selective detectors. And we have specific detectors, which will respond to only one specific compound and absolutely nothing else. The type of detector we will need to use is determined by the type of experiment we're performing. If we have a sample and we want to check if it has a specific compound, we can use a specific detector that responds to only this one compound. One type of detector is the flame ionization detector, and this is what it looks like. As to how it works, gases leaving the column are mixed with hydrogen and air and burnt in the presence of air. Here we see them entering and we see the flame that's going to burn them. Organic compounds will burn to produce ions and electrons, which can conduct electricity through the flame. So if we have organic compounds, which we usually use in this case, they are going to conduct an electrical current. So we apply an electrical potential at the burner tip, and we put a collector above the flame. The collector allows us to tell how many electrons were released, which will, in turn, help us identify the organic compound based on how many electrons are there. The electrical current resulting from the burning of an organic compound is then measured, and this will tell us how many electrons there are, and this will help us know what the atoms are.